screen?
Oh, not unless I let you.
I know. Please, may I share my screen?
Hopefully that's good.
Yes. Okay. So are you ready to go?
Yeah, we're ready.
Okay, so I just put together a little bit about the history of looking at Mars and what's happening this week. So the first recorded formal observation of Mars was done by Aristotle in 356 BCE. I'm sure for generations before that, people looked up and saw this reddish star and how it moved, but there was nothing formally put into print about it until then that we know of. And of course, Galileo in 1610, he looked at it and he actually recorded that there were phases of Mars, although I could not find any of his sketches, so I'm sure he would have done that. A fellow named Francesco Fontana. This is the first sketch that we can find about Mars early in the 17th century. Huygens in 1666 determined the length of the day of a Martian day, which is 24 hours, 20 minutes about. And Cassini in that same year saw that there were polar ice caps on Mars. The earliest sketch showing canals was found in 1840. We'll get a little bit into canals in a bit. Secchi, an Italian astronomer, confirmed the canals in 1858. And Schiaparelli in 1877, another Italian astronomer, identified about 60 distinct canal-like structures. He identified, okay, it's about 60. He never suggested that they were artificial or products of an intelligent life, but he didn't rule that out either. And he offered no explanation of what they were. He felt they might be a system for distributing water from the polar ice caps, which kind of thinks then you're thinking of intelligent beings on Mars. So while he was kind of suggesting life might be there, he certainly didn't go into speculating it or what his thoughts were about it. And then in 1897, Percival Lowell became obsessed with canals. He firmly believed that these were water canals made by a dying civilization trying desperately to bring water from the poles to agricultural lands. And where the canals crossed, he thought there was probably cities there. So he firmly believed there was an intelligent species living on Mars. It really, if you look into his observations a little bit more, he made these drawings, not eye at the telescope, but from photographs. But his photographs were like only half a centimeter across. And somehow he developed this theory of all these canals, and now we know most of them they're just humans' eyes trying to make straight lines. We seem to like to do that.
So all those canals, they're not all there, like this drawing?
They are not there. This is his sketch, but there are very few of these lines relate to anything. So last week, we had the HOPE probe from the United Arab Emirates reach Mars. It was launched last July. All 3 missions that are getting to Mars this month were launched in July. And it's going to be the first probe to provide a complete picture of the Martian atmosphere and its layers. It will help to answer key questions about the global Martian atmosphere and its loss of hydrogen and oxygen. And it's going to be studying Mars for one whole Martian year, which is 687 days, so almost 2 Earth years. That's its prime mission, and then hopefully it'll still be viable, and it can keep on going. You can see this little diagram here. When you launch from Earth, you want to launch where you think Mars, where you know Mars will be, not exactly to where Mars is in the sky. It takes 7 to 9 months to get to Mars, depending on your spacecraft, your launch speed, and your trajectory, all those kind of things. So it's going to orbit, just be an orbiter, do a peri-Mars, I guess, Martian, peri-Mars, and an api-Mars. So quite an elliptical orbit. And it's just got a whole bunch of different cameras and sensors and things like that. So that got to Mars February 9th. February 10th, the Tianwen-1 Mars rover, or Mars mission from China, did its orbital insertion on February 10th. So Tianwen-1 means questions to heaven. And it's going to be an orbiter and a rover. And but the rover is not going to land. Here we have a picture of it here. It's not going to land until May. So it's going to do lots of orbits of Mars, check out things. I don't know if they have a particular place they want to land, and they need to check it out first. I don't know why the delay, but that's what they're doing. Among its science instruments on the rover is going to be radar that could detect pockets of water beneath the surface, which would be really interesting. I don't know how much it can define what's in those pockets of water, you know, if it's just the radar, if there's any other sensing equipment to see if it's salt water or what. It'll be very interesting, though, to see if it does find any water. And you know, I'm always harping on liquid water and life. So if it can find some pockets of liquid water, and I also don't know how far down this radar goes, but if it could find liquid water, again, there just might be life there. And of course, the one that's going there this week is the Mars 2020. It will be getting to Mars on Thursday. The NASA.gov is just filled with Mars stuff. NASA TV, I think it starts at 11:15 Pacific time that day to cover the landing of Mars 2020. And I think it lands just about 5 minutes to 1 o'clock our time that day. So it's going to, here's its, I'm sure you've heard of the 7 minutes of terror. It's going very, very quickly when it gets to Mars. And although Mars doesn't have much of an atmosphere, it's enough so that when it slows down and starts dropping into the atmosphere, it does need a heat shield, and that will slow it down quite a bit. Once it gets to a certain speed, it can then deploy its huge parachute. Once it gets down a little further, it'll drop that heat shield off, and then it's got some very sophisticated and brand new instruments on this mission that will be able to photograph and radar and everything and check exactly where it is. It'll match pictures to what it has on board, and to see if it's in the right place. And if it needs to move at all, it can actually change its course a little bit to land at the optimal position. So once it's figured out where it's going, then it drops this kind of, it's called a sky crane, which slows down even more with some little jets. It again checks where it is. When it gets to a certain altitude, it drops the rover down on these wires. Once the rover touches, the wires have charges that cut them, and then it flies off to another place.
Whoa. How does it, is it all, is someone remote controlling it, or I guess it's all programmed to
It
land?
has to be programmed.
Right.
Yeah. You can't do anything remote control at Mars. It's too far away. At this point in its orbits, it's about 3 or 4 light minutes away, but this takes 7 minutes. So we won't know it's landed for several minutes after it has landed.
Yeah.
So all pre-programmed. This is exactly the same procedure that the Curiosity rover used, and that's the first time it was ever used, and it worked. I mean, there are a lot of steps that have to go exactly right here for it to work. And this one, with its improved telemetry, should work even better in that it can actually choose where it's going to land. And that makes it have a much smaller landing ellipse. Usually if you're just landing something on Mars, you've got a very long, maybe 100-kilometer landing ellipse that you know you're going to land somewhere in there. The landing ellipse for this one is, I think, like 4 kilometers by 7 kilometers, so very tight, so it can actually pick exactly where it wants to land. Much like Neil Armstrong, when he wasn't happy with where Apollo 11 was landing, he got to move it off a little bit. Let's see what else we got here. So it's landing in Jezero crater. So this is one of the major landmarks on Mars that you can see, Syrtis Major, and right up in the northeast corner of that is a little crater here called Jezero crater. So this is what Perseverance looks like. It's quite large. It's like the size of a van. And this is it, the arm with its really complicated picture imagers and samplers and things like that. Very complicated. And it will be able to search for signs of ancient microbial life. And strapped to its belly is a technology demonstration, the Ingenuity, the little helicopter. It'll be the first powered flight on another world, but it won't go until about 30 sols. SOLS is what we call a day on Mars because it's slightly longer. So 30 sols after landing, so about 31 Earth days after landing. It'll be dropped from the belly of Perseverance, and Perseverance will roll off, and then they'll check out the Ingenuity, and then it's just going to do little short hops, but really interesting in that it's another way, maybe getting above things, looking around at things, just so a demonstration technology.
Right, a little more kind of remote sensing there that we've never kind of been able to do, right?
Exactly, yeah.
That's super neat. Why are they, any idea why they're waiting 30 sols?
No, I have no idea.
I wonder if to get the rover to a specific location.
Probably needs to be a ways a little bit from it, and there's probably a whole bunch of huge checklist on what they have to do with the helicopter. Check that its rotors are going, its sensing equipment, and make sure it's healthy before it goes. So again, here's Jezero crater. We can see the crater wall here, and we can see that it had been breached by a river. So this huge river coming down, and it flooded this whole crater. It was a lake for quite a few thousands, maybe tens of thousands of years, and it formed this really interesting delta. And like I said, this is the landing ellipse for the Perseverance. So it's going to get itself somewhere in this ellipse, hopefully down in this area, but very tight compared with previous ones. And here's a bit of a blow up of this delta again. The colors kind of are referring to where they think there are clays. So this river came out very, it was breaking down Martian rocks and things as it tumbled along, broke through the crater wall, deposited this delta full of clays. And clays are, we think, are very important for life to start with. Clays are a little bit sticky, so molecules can stick close together and maybe start interacting, but they're not too sticky. So if a long chain of molecules forms, it can still be released into the environment. So clays are very important, and they think there's a lot of clays in this delta. This crater is about 45 kilometers wide, and it's located just above the Martian equator. And it's only going to be less than 4,000 miles from Curiosity's land. So we're really starting to populate Mars. The cool thing about Perseverance is it has a drill that's going to collect, samples of Martian rocks and soils and put them in sealed tubes and kind of cache them at a certain spot. And then there is going to be a return sample mission to Mars coming up in the next decade or so. It's also got an interesting instrument on it called MOXIE. So it's going to try to make oxygen from the Martian atmosphere. So the Martian atmosphere is about 1% the density of Earth's atmosphere. So not a lot there, but they're be able to break down any water that's in there and maybe some oxygen that's there and concentrate it. So that could be used for manned missions and for fuel. So once Perseverance gets all these little samples collected and cached, then there's going to be a Martian, where is that? The sample return mission. So this is what's happening right now, the launch and Perseverance on the surface of Mars, collecting all its samples and caching them someplace. And then in July 2026, this is not completely, all these plans are not completely finished. It's still working. I mean, first we have to see if Perseverance gets there and can actually collect these samples. So in July 2026, it's a combined NASA-ESA, the European Space Agency rocket. Not exactly sure of its configuration, but it will send a lander to Mars. Now it will should get there in August of 2028. I don't know why it's taking 2 years to get there. It could be that they're trying out different fuels. I don't know if it's an ion thruster as opposed to liquid, what propulsion that's under there. But it's got quite a window. So once this rover gets there, if it's working, it'll go and collect all these samples. If Perseverance is still working at that time, it might collect samples and take it over so we can get some pictures back and forth. That would be cool. Then once it's loaded, it's going to send a capsule out into Martian orbit. Meanwhile, in about, that's going to be in the spring of 2029. Now, meanwhile, there's also in October of 2026, and arriving in Mars in 2027, another orbiter, which once this sample pack gets there, the orbital will be able to collect it somehow and then send it off to Earth. And it should, we should get the samples on Earth in 2031. So it's a long ways to wait, but to be able to get real samples of, we have Martian meteorites. We all the rovers and things that we've sent already have been equipped with little chemistry labs, so we know a lot of the composition, but to be able to get samples to Earth and then really take them into a lab and really examine them will just open up our knowledge of Mars so much more. Okay, there.
That's super complex, eh? Like, wow,
Yes.
like just there's so many things could go awry.
And getting to Mars is really hard.
Yeah.
In the early years, there were way more failures than successes. But over these last few years, the technology and things have really come along. So we're getting much better. But yes, this sample return mission depends on Perseverance getting there and being able to collect samples for this guy to get there and collect them and send them off, and then this guy to get there and be able to catch them and send them. Very intricate dance of sample collection. Okay. So this is every Mars landing attempt ever. And we can see there have been quite a few successes. They're in red, so Viking, Insight, Curiosity, Phoenix, Spirit, Viking 1, Pathfinder, and Sojourner. That was the first little rover on Mars, and Opportunity. The failures are in this sort of light gray color, and there's been lots of failures. One failure was because somebody didn't see. NASA runs on imperial measures, the rest of the world is in metric, and there was a wrong conversion of the two. How horrible to be working on a mission for 30 years and forget to convert. Yeah, that's horrible. Anyway, and future missions, of course, Perseverance as of Thursday will be on excuse me, on Mars. Tianwen 1 is up there already, and of course the United Arab, but not landing until May, remember. And the Hope mission from the UAE is up there and orbiting right now. And this is a family portrait of all the missions that have gone to Mars. I just found this today, so I haven't checked it out exactly if they're all the failed missions. I'm sure there's a lot of fails, because I think I saw the Phobos mission here, which was Russian mission. It was going to land on the moon Phobos, and study that, and it got out there and we never heard from it again. We don't know what happened to it. So these last two I found on the Planetary Society website. There are full, that's where Bill Nye works out of. So a lot of information there, and a lot from the nasa.gov website. So a few other notable things that are fun on Mars. It has the largest volcano in the whole solar system, Olympus Mons. We can see it here, one of the ancient lava flows. It's about 500 kilometers across the base of it here. And it's 3 times higher than Mount Everest. Whoa. So Mount Everest, the tallest part on Earth, and in comparison, that would be Olympus Mons. So truly a huge volcano. This just shows the orbit of Earth and Mars. So we come into being close to Mars every about 26 months. And that gives us a real close window that, you have to launch when you're going to be close to Mars, unless you want to expend a lot of fuel, and that's just not worth it. So if a manned mission were to go to Mars, you launch, you spend 7 to 9 months probably in traveling there. You have to spend at least an Earth year before you can be in alignment again to get back to Earth. So really there's a lot of talk about setting up colonies on Mars. These are probably not going to be things that astronauts go to, live a while and come back. It will be true colonization. You will decide you want to go up to Mars and live there forever, and you will stay in one of these colonies. It's not an easy place to get back and forth to.
Man, I get my kids in a 2-hour drive asking me, are we there yet? Are
I
we
know.
there yet? Are we there yet? I'm not taking them to Mars.
7 months.
7 months of, are you there yet? Yeah.
Yeah, no, somebody will not survive.
Yeah.
And then there's always controversies about Mars. This was a picture taken in 1976 from one of the orbiters, and it was put out by NASA as a reason to get people interested in the Mars missions. And instead, it just brought every conspiracy theory out into the open about the face on Mars. Obviously, there's aliens on Mars. They put this face so we would find it and know that they're there.
I remember seeing that as a boy in the lineup at the grocery store, like
oh yeah,
like
yeah,
the Inquiry magazine or something like it. I mean, the
absolutely.
popped up a bunch of different times, right?
And over the years, more and more detailed pictures were taken, but the conspiracy theorists managed to slew every one of them to their way of thinking. So this was a little bit higher resolution picture, not so, this is very pixelated. So this one, we can already see it is not a face.
Yeah.
In 1998, there was this picture. It actually had kind of some frost on it. So the conspiracy theorists said, well, you're not looking at it properly. And finally, in 2001, we got this very detailed picture, which is kind of upside down to this one. You can see this kind of ridge along here. Is this kind of, actually, it looks like a cleft in it. Anyway, so, it's just a mesa. And I started looking into some more of them last night, and oh my God, there's pyramids. There's rocks that look just like that Sasquatch picture that he's walking along and swinging his arms. There's spoons and all this stuff that, they're just, we like to see things. There's nothing there.
Okay, you didn't just say that the Sasquatch is on Mars then.
There's a little rock.
Oh, okay.
That looks exactly like that picture.
Huh.
And so the conspiracy theorist said, see, there's even little Sasquatches.
Oh man.
Yeah, I know. And this is more of a 3D of that mesa. So, there is no face there. And I found a visitor's brochure, Trek Up the Face of Mars, and it had the pathway and everything. So maybe in the future that might be a visit, someplace to go to look at. So like I said, Mars takes 687 Earth days to go around, 1 Martian year. So they started looking, in 1955, there was a very big dust storm. And after that, they said, well, let's start that as New Year's Day. So that was year 1. This year, New Year's Day for Mars was on February 7th, and it's just the start of Mars year 36. So I don't know what you were doing that day, but you should have been hooting and hollering. I said 24 hours, 20 minutes, 24 hours, 40 minutes is 1 sol. And if you're working on a mission to Mars, once your mission gets to Mars, you have to work on Mars time. You can no longer work on Earth time. So everybody at NASA is shifting their time so they can work on that. Yes. And the original New Year's Day was planned. It was decided that the equinox on Mars would be the New Year's Day. And equinox is, so Mars has a tilt just like Earth does, so it has seasons. It's the vernal equinox, so the spring equinox, when So the sun is appearing to go higher in the sky in northern Mars. So that's the start of their new year. And that's all I have. So if you have questions or comments or things I should be doing, or
Oh, that was great.
I didn't have a lot of days.
No, I didn't give you much time. That was so informative. Here, Jake's got a question here. He's moved right in.
Of course he does.
I actually was just in the middle of watching the Mark Rober video on the Perseverance, and he showed this image. I don't know if you can see that, but it shows the different areas,
Yeah.
the different missions of the possibilities of landing. And the Perseverance mission is just this little circle right in the middle.
Yeah, yeah. That's because it has that ability to fly, and all those other missions, all the other missions, I heard one NASA guy explain it as, you know, somebody asked him, how do you know where to land on Mars, or how do you get to your specific spot? And he said, we send a capsule to Mars to where we know Mars will be, and we let Mars run into it.
Yeah.
Yeah, so the previous landing ellipses were quite large, and this one is just, hopefully it'll work out and it'll just be very tiny.
And this next mission is it's a really cool rover as well. Like,
Oh yeah, it's actually built on the Curiosity template, using a lot of stuff that was left over from Curiosity.
there's still a nuclear reactor on the back.
So I'd imagine they would have an exact replica of that on Earth, just like they did with Curiosity.
Oh yes, yeah,
Solve any problems, right?
yeah, absolutely, yeah.
They actually when they build these rovers, they build two of them, one for Earth and one for Mars. And
Yeah.
Exact copy of Curiosity in JPLs.
And they certainly used for Spirit, I think it was, they really used the one on Earth because it kept on getting stuck, and they had to test out how to drive, and a wheel would get turned, and can you drag it? Can you push it? Yeah. So they're really important to have that spare.
But the coolest thing was that capsule bit that you mentioned.
The return sample.
Yeah. And Mark Rover, he described it as the poop, scoop, and shoot method.
Oops. Yeah.
They poop out the sample, so another rover would come, scoop it up, put it on a rocket, and then they'd shoot it back.
Shoot it out. That's that's good. Yeah, yeah.
We do have a class coming in here, Colleen, so I just get
okay.
Wait, I want to hear what Newman has to say. He's been here for the whole time, keeping cozy at the back.
That's cool stuff. I like learning about Mars. I've been meaning to watch that Mark Rober video. I guess I'll do that now. It's on my bucket list.
Yeah.
With all the, I guess, missions. It's like, yeah, I knew there was a few, but I didn't realize.
Yeah. Yeah. Over this next little while, the information we're going to be getting is just going to be amazing.
Yeah, it gives me another reason to live a decade.
That's right. Yeah. Me too.
Well, thank you very much, Colleen. We got sorry to rush here, but yeah, we've got
no problem at all. You're very welcome. Thanks for the opportunity again.
Yeah, we could shoot for in 2 weeks at the same time if that works for you.
I'll have to check.
I'll send you a message and we'll see what works.
Yeah, yeah.
And if you're into it, that was a lot of fun.
Absolutely. Throw me some topics or whatever. Okay.
All right.
Sure thing.
Thank you. Bye-bye.